Okay, here we are again with some more quantitative chemistry, working out some empirical and molecular formulas. Now this example is actually more tricky than a lot of the ones you'll have to do with, but I think it's a good example to get you through just about everything you need to do. I think the first thing for you to remember, and the best way to do any problem, best way to approach any problem to do with the empirical formula, is to make yourself a table. Okay, so I'm going to start by making myself a nice big table with the elements which are present in the compound. Now here's a strange way of describing what the compound is. It's an oxide of phosphorus. It tells us it's an oxide of phosphorus because there are different phosphorus oxides. Well, we know then it must contain phosphorus and oxygen, or if we like, phosphorus and oxygen. And whatever you're given in a question, whether it's the amount of each substance, the mass of each substance in grams, or the percentage by mass, we do the questions the same way. This question gives us the mass as a percent, and there's 56.4% of phosphorus and 43.6% of oxygen. Of course, if they just told you the percentage was of phosphorus, you could work out the percentage of oxygen because you know they add up to 100. So we've got our masses as percentages. In other questions that might be grams. Same thing. Next, the relative atomic mass of the substance we're using. Well, phosphorus has a relative atomic mass of about 31, and oxygen of 16. Note, I've said 16. Some of you will be thinking, but oxygen is diatomic, so I'm going to put in a mass of a relative atomic mass of 32. No need to do that. It's oxygen, it's in the compound, and it's got a relative atomic mass of 16. Now, the reason we do that is to work out the number of moles of each substance. And we do that by dividing the percentage mass by the relative atomic mass. So divide this number by this number, and if you do that, you get a value of about 1.82 for phosphorus. And if you divide this number by this number to get the number of moles, you get about 2.725. Now at this stage we can't see a nice whole number ratio. Remember, empirical formula is the simplest whole number ratio of atoms in the compound. When we get to a stage like this, again, the same rules follow. We divide by the smallest number. Well, the smallest number is 1.82. That's smaller than 2.725. So divide both numbers by 1.82. 1.82 divided by 1.82 is 1. 2.725 divided by 1.82 is 1.50. Now, when we get to something like this, we do not say that 1.50 rounds up to 2. It's a long way away, okay? If it was 1.98, okay, that's nearly 2. If it was 1.1, okay, that's nearly 1. But if it's close to a half or a quarter, we're going to find the whole number ratio. And if we multiply both of these numbers, if we multiply 1 by 2, and if we multiply 1.50 by 2, we end up with whole numbers. We end up with a 2 and a 3. And that's what we want, a whole number ratio. And so we can say that our empirical formula is equal to P2O3. Now the question wants us to find the empirical formula. We've done that, but it also wants the molecular formula, and that's why it's told us that the molecular mass is 220. Well, if we know the molecular mass is 220 and we know the empirical mass, we just add up all of the atoms of the elements in the empirical formula. Empirical mass gives me, using my periodic table, 2 multiplied by 31 plus 3 multiplied by 16, that gives me 110. I can see that the molecular mass, 220 divided by 110, gives me 2. So I know that my molecular formula is twice the empirical formula. So my molecular formula is P2O3, or twice, which gives me P4O6. I've run out of space. P4O6. Done. Remember, whether you're given percentages or grams, just do it the same way. Okay? Same way. Mass as a percentage or mass as grams, divide by the relative atomic mass to give you moles, divide by the smallest. That might give you a whole number ratio. If not, find integers, whole numbers, to multiply by in order to get you that whole number ratio. And there you go. Questions might be set simply like this, or even you can do questions like this when you're trying to work out number of moles of water of crystallization. Use a table. Great. See you later.